students, so this question is a very important question and it's a very tricky question actually. So let's be very careful when we do something like this. All right, so if you look into this question, what you find is that you have two charged particles, okay? The mass is known, they're identical, and they're moving with the same velocity. The two particles are equidistant from the vertical y-axis. So this distance is 0.5, this is also 0.5. The only thing is one particle is above the x-axis by a distance of 1 meter. At some instant, the magnetic field B is switched on so that the two particles undergo a head-on collision. So what is the direction of the magnetic field? First we have to find, and what is the magnitude of the magnetic field. So our final goal is that they move in a certain manner so that the collision happens, right? If they are moving parallel, the collision will not happen. So the moment you apply the magnetic force, right, what happens? Centripetal force starts acting on it. So one of them will start going up like in a circular motion. The other one will also start in a circular motion in the downward direction. That is the only way you can have a collision. It is not possible that the lower one goes. So this is my lower one, okay? So this is my lower. If it goes down and the upper one goes up, collision will not happen. The only way collision will happen is if the lower one goes upper and the upper one goes and they collide, right? So we are very sure that the magnetic force on the upper one should be downward and on the lower one should be upward. We know it's a centripetal force, but at least we have a sense. Now, before I solve this problem, I will explain you using my right hand rule how to calculate the direction of the force. Okay. So keep your palm like this, parallel to the facing the ceiling. Okay. Keep it like this. The direction of my palm is the direction of the magnetic field. So my magnetic field is going inside. Okay. The thumb represents right hand, remember. The thumb represents the direction of the velocity. If the situation is like this, that the magnetic field is going in and my thumb is here, draw a perpendicular on top of the, like this, upward. Perpendicular to that is the direction of the force. So keep palm like this, keep it, if you keep it inside, the velocity is in this direction, the force is upwards. If the field is towards me like this and the velocity is still in the same direction, the force is downward. Okay. So use right hand rule always to identify the direction of force. There are many ways you can do. You can use a palm rule also, which I just explained. This is same as a right hand rule. Let's look into the question. We discussed that we want this charge to go down, right? We want this to go down, okay? And we want this charge to go up, okay? Now, let me guess. My guess is that the magnetic field will be inward. So let me just do it. The magnetic field is inward. You can see my fingers. They are coming inward. My velocity is leftward. Because I'm using a camera, so you will see reverse, but I am moving leftward. So you also do this. Don't think I'm moving rightward. I am moving leftward, okay? Because the velocity, so if I move left, if the velocity is left, my magnetic field is inside, you can see the direction of the force will be downward. So if the field is inward, the direction of the force automatically comes to be downward, which is what we want. But let's talk about this. For collision, this should go up. They should move towards each other. How, we will see, but right now we're deciding what is a magnetic field force. So this body is, I am again keeping my fingers inside but I have to reverse the direction of my velocity. So but this is my velocity, my fingers are still inside. So my force is going to be upward, right? The force is going to be like this. My velocity is rightward on the lower particle. The field I have chosen, I've guessed, is inside. The force is upwards. So the force is upwards. This is exactly what we want. We want that they move towards each other somehow for them to collide. So my guess that the magnetic field is inside is correct. So the first answer is that the magnetic field, okay, the magnetic field is inside, because it ensures that the charges are moving towards each other. Let's go to the part 2 now. Complicated. How will they know what is the magnitude of the field so that they strike each other? Okay, let me just rub off whatever I have written. Now we know the magnetic field is inward. We know the direction of B is known, but the magnitude of B is still not known. Okay. Now, if you remember, if a body has a velocity in the horizontal direction and it is exposed to a perpendicular magnetic field, right? Say this is the perpendicular magnetic field it is exposed to, right? So this is a positive charge. It goes like this, right? Because the magnetic field is suddenly switched on, so that the two particles undergo a head-on collision. So this particular particle and the other particle, suddenly when it faces a magnetic field, what happens to it? It also, the moment it also starts undergoing a circular motion. So it was here and now it has started doing a circular motion, right? So essentially what is happening? The direction of the force is centripetal. BQV, which in fact is written like QV cross B, is the magnetic force being experienced by these two in the upward and upward and downward direction, but centripetal, right? It is not a straight force so it is perpendicular always to the velocity. I said the forces are up and down, but they are not linear forces. They remain perpendicular to the velocity always. If the velocity here is V, the force will remain perpendicular to it, because the motion has to be circular motion. Now, if you see this will start executing a circular motion like this. And this too will start executing a circular motion like this. So both are some small circular motions, part of circles. I will just draw a better diagram like this, right? So they collide here. So by symmetry, right, you can see by symmetry what will happen. One, the radius will be identical. Why? Because the charge is same, velocity is same, magnetic field is same. So the force will be same, and therefore force can also be written as mv square by r, centripetal force, right? So qvb is equal to mv square by r. I cancel the v, so r becomes mv, the momentum, divided by qb. So the radius is also identical now. They will move in an identical manner. The radius also becomes identical when they collide, right? But we are worried about what is the magnitude of the magnetic field. We have understood that the radius is equal for both of them and they will collide at a certain point which is symmetrical, right? It cannot be that this covers the lower arc becomes larger than the smaller, so upper is smaller. No, the arc size is also identical, for the simple reason that you are talking about both sides are identical. So the circular motion they take is also identical, and therefore the radius, this radius and this radius is identical. That is what we need to know, that the radius is going to be Same. Now we have to calculate what is the magnitude of B for which the collision will happen. We have understood the bare minimum, condition for them to collide, the directions. This is some circular motion. This is also circular motion of radius. So, and they collide here, right? So they will collide on the y-axis, by the way, because they don't have a choice, right? And they will cover equal distance also. So if it is total is 1 meter, if the total is 1 meter and I'm coming like this, I will cover 0.5 meter, and the upper, which is, okay, let's this be the 1 meter. Okay, so the total was 1 meter from here to here. So the lower radius will be this and upper radius will be this. So they have to collide in the middle, right? So we know that if they collide in the middle, the radius we are talking about, right, is how much? The radius we are talking about is, if this is the center and this is where they collide, the radius we are talking about is 1.5, right? So it will collide like this and this will. So essentially we are saying these are two circles which are like this, okay? So, and the upper circle is like this, and they collide here, right? And this total distance from bottom, okay, from the bottom to the top is 1 meter. So this is half meter and this is half meter. So we know the radius also. So the radius is 0.5 meter. So 0.5 is equal to mass of the electron multiplied by the velocity, which is 2.4 into 10 raised to power 5 divided by the charge 4.8 into 10 raised to power minus 19, and the velocity, right, in the denominator. Sorry, the value of B has to be put, which is what we need to find, right? So B into B. So B will be equal to B. We have to find the value of B. So B will be mass into velocity. So how much is a mass? 4 into 10 raised to power minus 76 multiply by charge. Sorry, divided by charge. So charge is how much? 4.8 into 10 raised to power minus 19. Okay, and Q, right? So now I have to multiply this with velocity. 2.4 into 10 raised to power 5. I think little space left, and I have to write another value, which is radius, so into 0.5. So 2.4 2s are, and 2 into 0.5 will become 1. So in the numerator this will become 4. Okay, this is 26. Okay, so the minus 19 will go up. So this will become 4 into 10 raised to power minus 7 into 10 raised to power 5, because this 2 into 0.5 is 1. So so this is 4 into 10 raised to power minus 2. So 0.04 Tesla. This is your magnetic field. There is no other way you can think about it. If they are not identical circles, they will not collide. So we have to use some understanding of the situation, that the radius has to be like this. Okay, so one radius is this, the other radius is this. This is the only way we will be able to. Otherwise, they will. They have not mentioned exactly where they are colliding, but this seemingly is a very reasonable assumption on the point of collision. Okay, so I hope this question is clear to you. It was intuitive, it was a bit mathematical in nature. I use symmetry on both the sides. Identical charge, identical velocity, identical mass, distance is known. So let one cover half meter radius and let the other also cover half a meter radius, and they collide right at the middle. So the point at which they collide, I found out using symmetry. Then I used that to find out the distance, radius of the circle to be 0.5 meters. Then I substituted that in the formula of the centripetal force is equal to QVB. All right. So I hope you like this video. Not a very easy question to do, but it involves knowledge of circular motion, maths, understanding of collision to an extent. Not really the collision as in momentum exchange and all of that, but it does test you for some understanding of motion, kinematics, more of circular motion. But you should be able to visualize what type of motion will result in a collision. Okay, I hope this helped you. Please don't forget to subscribe to this channel. Fantastic questions coming your way, and you will be able to do very well in your exam if you subscribe to this channel. Almost 3,000 problems, concepts, theories already available. Thanks a lot.